I'm going to talk about things that, well, apparent wind, and then comparing an ice boat sail to an airplane wind. And you can't do that. They're two different things. First, we'll talk about the apparent wind. Everybody thinks apparent wind drives the ice boat, right? You think that? Or they don't think that?
Not sure.
You're not sure.
Sure.
I know, that's a lot of people are. Not sure. There is no velocity at all to apparent wind, none whatsoever. Now, and I'll show you right here. If you have, now these are equal lengths, so that's, this is the wind blowing down. This is your boat going across, and then this is apparent wind, right? Everybody gets that? Okay. You have velocity this way with the wind. You've got velocity with the boat, but there is no velocity to apparent wind. And if you see like these, these are these balls or particles of air, molecules. If they travel the same distance, they leave at the same time, they're the same weight, the same size. As they come and collide together here, they collide here at a 45-degree angle. Well, that's a not that there's any velocity in this angle, right? But it's a collision. They're just colliding into, so it's a pressure. The problem is when you see videos on YouTube or something about apparent wind, and they talk about they hold up an anemometer, it's showing that the apparent wind is blowing more than the true wind because there's more pressure. Because this does not measure the speed of the wind. It's a pressure sensor. That's all it is. It measures pressure. And it's the pressure of the collision with air molecules is what it is. With the stuff you feel on your face or you're sailing along and you feel like the wind coming from the side. So that's just the pressure of clouding into the wind that's going, the opposite, 90 degrees to you. I'll get that?
Yeah.
Kind of, sort of? Okay. So there is no velocity at all to appear. It does not power the boat at all. So what does power it is, we call it the stream effect. And the stream effect is like this. Just a stream of air, as wide as the lake is. You can think of it as flowing over the lake like a plate of glass. If you moved across the top of a table, it just moves like that steadily across the lake. Now there's individual molecules of air, but they all move together in sync. If there's no other obstacles and anything in the way, it all moves as one. And so there's three different components to the stream effect. And the first is wind flow, and the second is wind shift, and the third is direct downwind drive. Now wind flow simply says the wind flows downwind. That's the only place it goes. If you draw a line, the wind's coming down here, you draw a line across here 90 degrees, the wind only goes down below that line. It cannot go back up against itself, right? Okay. So that's the first part. And then the second is wind shift. And wind shift, this is my sailboat, by the way. The one represents the center line of the boat. The other is the sail. Sail's way out, sail's all the way in. All right. So I'm just going to hold it like this, though. This is the sail. So if the wind's coming this way, this is the mast. Now wind shift. The wind that's coming in hits the front of the mast or the sail. It has to shift, and this is 8 feet, and this is 8 so it has to shift. See, it's an 8-foot boom like a DM. It has to move over this, and this sail is standing here. It has to move over 8 feet to get around that sail. And it doesn't go back to where it was. It continues after it shifts lanes. It only moves that distance when the boat's standing still. When the boat starts to move, that wind shift becomes shorter and shorter and shorter. Everybody understand that? Relative to the ground. If the boat's going if this is 8 feet and the boat's going 8 times the speed of the wind, it only shifts over a foot. There it comes down, hits the sail, starts moving across the sail, and boom, the boat's already by, and then it continues on its way. All right. So that's with the wind shift. And you have to keep that in mind because it takes place upwind, downwind, wherever you sail. So we're going to go back to the okay. When you sail upwind, the wind comes across, it's coming down, hits the front of the sail, and the boat's moving by, and the wind goes this way across the sail, downwind, and the boat moves by and it continues on its way. Okay. Now, when the boat is going downwind, which way is the wind going? It does the same thing. The wind hits the boat at the front. The wind moves forward across the sail. Moves forward across the sail. And then as you go by, then it goes downwind.
It goes backwards, upwind, and forward down.
Yeah, when you're sailing upwind, it flows normally across the sail. And it happens on both sides of the sail. When you're sailing downwind, it flows forward across the sail. And that takes place on both sides of the sail. And your telltales are always streaming backwards because this wind will say it's moving at 10 miles an hour. So it comes down here at 10 miles an hour. It gets slows down a mile an hour because it absorbs the energy. So it's moving across, we'll say 10 miles an hour. This boat's going 40 miles an hour, right? So zoom, the telltales are still streaming backwards. You can't tell that the wind's moving forward across it, but it is.
Could you put that in a wind tunnel?
A wind tunnel?
If you set it up in a wind tunnel?
And I have a wind tunnel that we did for it, but what
I was just wondering if you could actually see the
you can't
smoke.
you can't see it. Now what
Because you have
brought
to
it
have
to
a
my
movement.
attention was if you watch the snow on the ice sometimes and you'll see it, it'll flutter up in the air. And as you go by, you'll see something strange happen with that snowflakes, you know. If you pay real close attention. Now it's really apparent on a skeeter, because a skeeter runs about 8 times the speed of the wind. It's very efficient. That's how you tell the efficiency of a boat. How fast you can sail, you know, the boat speed, wind speed ratio. All right. So now you know something to do. The wind flows downwind or flows forward across the sail when you're sailing downwind. And now the other thing is, the other third component is direct downwind drive. This is pretty cool. Now this is like the real physics. I gotta sit down so I grab my stool. No matter what direction the boat is sailing, whether it's going directly downwind, 90 degrees across the wind, or pointing real high and fast upwind, the sail is always moving directly downwind. Did you know that? The sail is always moving directly downwind. When the wind blows on something, whether it's a leaf or whatever, where is it blowing? What can it do with it? It moves it downwind. Right. And so that's what takes place with sailing too. It moves it downwind. It works like this. Now, this is the wind running downwind. Now this is the 90 degrees across the wind, it's running downwind, running upwind, how are you going to look at it? All right, this is my boat. So the boat is, I'll put the center line, we're going to run 90 degrees across the wind. Now I'm going to put it out here. The boat's not going very fast, right? We don't have it sheeted in real hard. But it's out here, and it's moving across the wind. Now the wind hits it right here. The wind hits the sail. Now look what it does. Look what it does to that sail. Where's it going? It's pushing that sail out of its way, downwind. You see that? And I can close it up too. It still does the same thing. It's not as far. It's moving it downwind. Now, it moves it downwind at a certain rate in all directions. And that rate is slightly under the speed of the true wind. Because it has to slow the wind down, right? It has to, this part of, when you're sailing downwind and you're going faster than the wind, the whole boat is not going faster than the wind. You think it is. But it's this point where the wind contacts the sail. It never goes downwind faster than the wind itself. I can do the same thing going up. As they move it up, it keeps pushing that sail downwind, 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 all the time. It's always pushing it downwind, directly downwind.
Does it make any difference which side of the sail?
Which side of the
lee
sail?
side or the windward side?
Doesn't matter. It doesn't matter if you're going this way, is that what you mean?
I mean, it's, you know, like, here's, I can understand where it's
Well, the
hitting.
windward side or the leeward side of the sail.
Is it the same? It's always going downwind no matter what, on either side?
It's always, the sail is always moving downwind.
It's just the runners that are counteracting it.
The sail, well, yeah, your runners are, the boat is holding, this is the boat, this is the direction of travel.
Well, I can understand on the windward side of that sail,
Yeah.
it's pushing it down. What about the leeward side?
This side of the sail? Well, what about it? I mean,
Oh, that's right.
it's moving downwind.
Same thing.
Everything's moving downwind.
Just go along for the ride.
Yeah, it's always moving directly downwind. It's direct downwind drive. And that, and like I said, when you're driving directly downwind, you're going downwind, but you have to go slower than the wind, right? Because of friction, and even if you thought you would go as fast as the wind, you can't, because you have to capture the momentum of the wind, and that's what's going to pull it down, pull the boat along. It has to be slower than the wind. If you were to go fast downwind faster than the wind with your sail out, you would bag the sail the other way, right? You're going downwind, you'd be pushing out. Do you ever see that, I talked about the Blackbird, that direct downwind machine, that the vehicle that goes directly downwind faster than the wind? It does go faster than the wind downwind, except they really don't know how. 3 years ago, there were some physicists, Bill Nye science guy, who's the other guy?
Veritasium. Well, he has a channel on YouTube called Veritasium.
Yeah, who's
He's
that?
just some scientist.
Neil deGrasse, or what's his name?
Yeah, Neil deGrasse Tyson.
Yeah, Neil Tyson, yeah. They made a bet, $10,000 bet, to see if that was really occurring, you know, where it really moved downwind faster than the wind. And it turns out that they agreed that it does go downwind faster than the wind, but they don't know how. But I'm going to explain to you how. And this is the. Now I did contact this guy.
You said Blackbird, you mean Greenbird?
No, Blackbird is the one. It's just a.
It's a different one?
It's not made for a land speed record. It's made for just going downwind,
Oh, okay.
directly downwind.
And that has a propeller.
It has a propeller.
Yeah,
Yeah, it has a- yep.
Oh, okay.
It has a propeller, just kind of like this. And so this is what takes place. Now normally when the wind hits this, it would turn this way, right?
Yeah.
By blowing it. Okay. So their boat is looks like an ice boat, and it has wheels on it. It has a plank and a steering wheel in front, and it's chain. It's got an axle across it, a solid axle, and it's got a sprocket, and then on the axle, a sprocket up on the shaft here, the propeller. Except it's geared so that it turns in the opposite direction. So when the wind hits it, it's turning this way instead of going this way the way it should. It turns opposite. In the boat, or the vehicle is moving downwind. Now, what they're saying is, and they're really not sure, but they're saying that, well, the wind, it's spinning downwind, it's like a fan blowing against the wind. That's not possible. Like they said before, the wind only goes downwind. It's the only way it can. And it can't go. So what happens is, you know, how we talked about the wind goes forward, moves forward when you're running downwind. Well, that's what happens with this too. As a propeller, as it's turning this way, the wind hits it in front and moves forward with it. Only this is spinning fast, and the wind moving forward is moving slower, and it drops off the back. So the same thing happens here. The wind hits it, moves forward across the sail, and that's what makes the boat go downwind. And it can go downwind faster than the wind. That was
Like 2.6 times the speed of the wind.
Sometimes the speed of the wind. So anyways, that's my presentation.
Was there a ratio between the two axes on that?
On this,
color?
on this here?
Yeah, between that.
Yeah, they had many different, in fact, the pitch is variable on it,
Okay.
and they had many different gear ratios before they found the appropriate ratio that,
Okay.
see, because what happens is, what's happening is when this works just like the sail does when you're going downwind, okay? So when the wind hits it, you're running downwind. It hits it, and it's, you know, this is unscrewing is what it's doing. It's unscrewing when we're going downwind. But if it was stationary, it'd be just like the ice boat, going downwind. When it hits it, goes it, keep going downwind.
Okay.
It's just like that. I don't know.
That's not legal though on a boat.
Does that make sense? Does all that make sense?
So here's like, the question is apparent wind terminology that should be scratched off the vocabulary?
Well, that's just it. Apparent wind is apparent. Apparent, definition of apparent is something that's not as it appears to be. And that's exactly what apparent wind is. It's not, there is no velocity to apparent wind, none whatsoever. It's just a collision of you into the air molecules, and that's all it is. And it's the highest pressure. Wherever, the faster you go, you know, it spins around in front of you. The faster your boat goes or whatever, it comes around in front of you. But it's the same thing. You're just colliding with air molecules, and the pressure is, you know, all your skin and everything is a pressure sensor. You can feel it shift around, you know, and that's all that's taking place. That's what apparent wind is. It's a deflection angle as you're colliding with the air molecules.
So, you know, in comparison to a wing, and you talked about that when you first got up there, comparison between a sail and a wing,
Yeah.
and the theory of lift. And I've been told that the wind goes faster across the back side of the sail than it does across the front side of the sail, or the
Right.
windward side versus the leeward side. But actually, and I've gotten into this whirling vortex of information that you've obviously gotten into watching these videos, and it leads to the next video, leads to the next video, and you're gathering this information. And one theory that I ran into was the fact that the wind, the speed is increased on the windward side of the sail, and the leeward side of the sail has a longer distance to travel.
Lower pressure.
But they meet at exactly, the wind molecules, the air molecules meet at exactly the same time once they exit the sail.
You're kind of right, but this is for an airplane only. It's not for the ice boat.
Well, I was comparing a
What-
sail to a wing and just
Yeah.
looking down at it.
As the molecules come around, they don't meet exactly because it's a longer distance, but it's the same pressure. It's the same
But it's
pressure.
the differential in pressure, or
Yeah.
in speed.
But see, here's what
pressure.
happens in a with a wing, with an airplane. It's the deflection angle is upwards, right? It's in the direction that it's moving, making lift. But on the with the boat, you know, and that's the leading edge. That's up, right? With a boat, it's actually down. Your boat. This is attached to the mast, and you're moving in this direction. You see what I'm saying? It's completely opposite. It's completely opposite. And here's what also happens. With a plane, the wing, the air is actually still, right? The air is still. Air is not moving. The plane, the wing provides the energy, the momentum that moves along, hits that. And what happens on a sailboat or ice boat? It's the reverse. The wind is providing the energy, moving along, momentum, and the sail is just sitting there. You can't even make the comparison. They're completely different things that take place. Yeah. You can't have the wind blowing forward across the sail, going downwind, and tell me that the wind's going over the sail, creating lift. It doesn't happen because the wind is actually going across the sail backwards, right? So they're completely opposite.
Is it the apparent wind?
There is no apparent wind. Right? There is no apparent wind. The wind is always flowing downwind. No matter it does. There's no apparent wind. There's none of that. The molecules are always flowing directly downwind, and they don't want to alter from that. They'll hit the sail. Any deflection.
What is it that's making my telltales flow backward?
It's just this. You're just running through it real quick, and your telltales are just flowing behind it. That's all.
Okay.
Yep, that's all. It looks like it's counterintuitive, like you're saying. It looks like there's the wind, but the wind, there is no wind blowing it. It's just sail going. The wind, that wind that hits the sail goes forward is going slow, say 10 miles an hour, where the boat's going 40 miles an hour. So it's just pulling that telltale right on through it like it was
So
nothing.
when you see the telltales going forward, guess what?
Well, yeah. See, I mean, you can see this when the boat is standing still. If the boat is standing still, and it's aiming downwind, okay, and you'll see those telltales. It'll hit the back of it'll blow those telltales forward. All right. So if you hold that tight, that bolt tight, and let it start moving, it'll still start blowing, and then you'll see it. It'll angle upwards. And it'll start flowing backwards. But it's not. It's because the boat's taking off faster now. But the wind is still moving forward across it. It's counterintuitive. You're seeing that telltale, and you think, oh, okay, well, it's the wind, but there is no wind blowing. It's blowing forward across the sail. Now, I'm putting this together and applying for copyright for this, but it doesn't do anything. But it just says that on a certain date. This is my conclusion here. So it's kind of cool stuff.
Yeah.
So you're.
And that's
wind's
we're
going that
videoing.
way, but you feel wind in your face.
Yeah. It's because you're moving
Faster.
That's pressure, that's right.
Pressure.
Yeah, you're always moving faster than the wind. You're always colliding with the wind. You're running 90 degrees to the wind. You're colliding into the wind. But the wind is always moving directly downwind. It never moves forward against the stuff like everybody thinks. Well, okay, the telltales are flowing backwards. God, the wind's got to be going backwards, but you can't, can it? You can't go backwards against it. So
Well, it's a turn. It's
Yep.
actually, right, it's always going downwind.
If you think about it long enough, you're gonna throw up.
But it's really hard for you to sail down, sailing, and not think that wind's coming through the sail this way.
right. It's because it just visually looks like it is, and it's like I say, it's counterintuitive because you just think.
Can I say the molecules have changed when through the sail this way?
The molecules are always going.
Molecules
are
always going down.
Always down. Always,
Whichever way the
always.
wind's going, it's that way.
Always down.
So when you're going downwind, Basically, the sail's pointed that way.
Yep.
and the- You're going this way, and the wind's going that way.
Yep, wind is going forward across the sail. Doesn't, it starts in the front, but the boat is going so fast, it's going, and the molecule, it's still moving forward, but it's going a whole lot, so it gets to the back, and it drops off the back, then it continues on its way. It moves over a foot. You can just kind of picture the boat moving, it's, say the wind is running downwind, and you're going across it. And the wind just comes, sees your boat, and says, okay, it just jogs around it. Phew, the sail goes by. It's not flowing across the whole sail or anything. You don't get high pressure on one side. No. It's just, like I said, 'cause the wind flows across that sail forward on both sides of the sail.
But when you're going downwind, since the wind's coming this way, and your sail, the wind is actually going, starting at the back of the sail, moving,
No, it starts at the front of the sail.
even though the wind's, let's say
Even though-
you're headed there.
Yeah,
And the wind is from here,
from behind, yeah.
but the wind is that,
It still hits the sail in the front
because you're moving.
because the boat is going so fast. And that's what makes a boat. Now this is some cool stuff. They have, now what do you think the top speed of a wind-powered vehicle is? Does anybody know?
Frictional.
Oh, I've seen that.
It's high.
It's in the hundreds.
It's in the hundreds.
Yeah, it's
Yeah,
way up there.
it's 500, it's over 500 miles an hour, a wind-driven, now it's a glider is what it is. It's a radio controlled.
With no friction.
Yeah, it's only a flying wing. It's, they call it dynamic soaring. And it's, so there's a bluff, and the wind is blowing across the bluff, and it comes up over the bluff. And the back side is a low pressure, and so they fly it, instead of flying it, these gliders on the front side and just kind of soaring along. They're on the other side of it, and they're coming around with low pressure, coming up, hitting this wind, and they're moving forward, and they accelerate until the wind starts pushing them back to wind speed, and then they fall off, and they do the same thing again. And they go round, round, round. If you see it on video, it's amazing. So that's the potential of a boat if it didn't have the structure and the cables and all that stuff slowing it down. When the wind hits the sail, this is just, it hits the sail and it moves, if you're going upwind, it moves backwards. So this is the molecules that are here. So the molecules that hit it here, they're really not hitting the sail cleanly. They're ramming into the molecules that are flowing backwards already. That's why the longer you have the longer the boom is, or the wider, it's just drag. It's just more and more drag. All the power of a sail is made of the very forward part of it. As it's moving forward, each time it collects more and more clean air molecules. And as soon as that molecule makes that turn, it's wasted. Its usefulness is done.
So that's why a high aspect.
That's why a high aspect of a blade sail is
much more
it
efficient.
makes so much more efficient. Well, I hope you guys enjoyed that.
Yeah, it's interesting.
And now we know Skip's up to something. Now we know Skip's up to something.
Yeah, right. I thank everybody for listening.
Yes, well, thanks for bringing that. Now you've got our heads all.
Yeah, all right.
Moving the alley and clean ice.